So we have our today's session speaker with us, Dr. S. Ghosh. Welcome, sir.
Yeah, am I audible? Hello?
Sir, am I audible?
I can hear you.
Yes, Priyanka, you are audible.
Yes, sir. So Ghosh, sir, voice is breaking, I think.
Okay.
Hello? My voice is clear or not?
सर आपका वॉइस ब्रेक हो रहा है सर.
Okay, just a minute.
अभी भी ब्रेक हो रहा है सर.
Sir, now it is clear. Voice is clear.
Now it is clear, sir.
Okay.
Good afternoon, sir.
Good afternoon.
Okay, Priyanka, you can start and then we'll hand it to sir.
Yes, sir.
Okay.
So our today's session speaker is Dr. S. Ghosh. Dr. Ghosh is currently working as an associate professor in the Department of Electrical Engineering of National Institute of Technology, Raipur. Sir has received his doctorate degree from IIT Kharagpur and he has published more than 70 research papers in various international journals and conferences of repute. Sir is having more than 10 years of experience in teaching. He has received Best Paper Award in IEEE International Conferences on Computational Intelligence and Computing Research, Best Faculty Award 2020 from NIT Raipur. His research interest includes optimization, system modeling and control, and renewable energy. So, thank you, sir. And now it's over to you. So, can we start with our session?
Yeah, I'm sharing. Just
Okay, sir.
I suppose the slides are visible to you.
Yes, sir. So it's so please put it in Zoom mode. Yes, sir.
Okay. So good afternoon to all of you, and thanks for the introduction, Priyanka. So on this, as you know, that I would be basically discussing about optimization, and to be more precise, I would be discussing about heuristic optimization. Particular domain of optimization which now is more popular as compared to other domains, and I will start with the basics of optimization, why it is required, and then I would be coming down to few specific applications in biomedical engineering, okay, or in health engineering, whatever you talk of. One is related to the design of digital filters for certain biomedical applications, and one application related to biomedical system modeling. Okay, so starting with the need of, and by the way, one thing I would like to please make it clear, you can interrupt me in the during the course of my presentation as many number of times as you want, and until and unless you interrupt me and ask you some questions, then I think the objectives of this particular presentation will not be fulfilled. Okay, so please ask some questions. That questions may be the most basic one, and it may be directly related to what I am discussing here. It may not be directly related, it may be related to your field of research. And if you have a certain thing in mind that you are working in a certain domain, and there you want to apply optimization, what are the challenges that you are facing, and if you are trying to implement it it in any software package, mainly MATLAB or this Python, what is the problem that you are facing and things like that. Okay, so please ask questions, and if at all, if anything is not clear, you please interrupt me and try to clarify it. Okay, so this is how I would be proceeding during the course of my presentation. First, I would be discussing about the motivation for optimization. Why at all do we need optimization? The motivation for applying optimization in their field of research is different for a person who is working in electrical engineering, who is working in mechanical engineering, or who is working in biomedical engineering. But one thing you keep in mind is that you may apply optimization to solve your problem. A person working in mechanical engineering may apply optimization to solve their problem. The formulation of the problem may be different, but the techniques are same. Okay, so there are two things that are basically associated with optimization. The first thing is the formulation of the optimization problem. Okay, when I talk of the formulation of the optimization problem, this particular formulation is application specific. Okay, application specific means that somebody who is working on DSP will have a certain different formulation for the optimization problem. Somebody who is working on DIP will have a different formulation for optimization problem. So once you have convinced yourself that you want to apply optimization to solve your problem, the second thing that you have to do is that it is basically like a flow chart. You have to formulate the optimization problem, and then you have to choose out among the techniques. So the first thing that you have to choose out for is that this is the most common approach by which optimization techniques are differentiated. One is what you call it as the local optimization technique, and the other is what you call it as the global optimization techniques, right? So global optimization technique is something which we all should, most of the times we go for global optimization technique. What is the basic difference in between the two? After some point of time, I will try to make it clear. And then in this presentation, I would be discussing about a particular class of global optimization technique, which we call it as the heuristic optimization. I think there are many types of heuristic optimization techniques. Like I am naming a few. You have genetic algorithm, you have PSO, particle sum optimization, you have differential evolution, and then you have artificial bee colony, then you have teaching learning based optimization and things like that. Okay, then you have J algorithm. Okay, and then you have artificial bee colony. In the course of the presentation, I will come down to more of it. There is something called grasshopper optimization and things like that. So I would be discussing about a particular class of optimization techniques which come under global techniques, and they are known as heuristic optimization. And heuristic, as you know, is basically it means that we are not applying a particular analytical approach, and we are basically moving in an ad hoc manner to solve the problem. In that case, we call the optimization problem to be heuristic. And then I would, as I had said, I would come down to some specific applications of optimization in biomedical engineering, and one is related to differential evolution. This is a technique, and with this technique, we would be solving a parameter estimation problem. Okay, this I suppose you would find that this is parameter estimation is something you do when you have a biological mathematical model. Okay, you have a biological mathematical model, and that mathematical model is representing a particular physiological phenomena. I would be taking a mathematical model related to glucose metabolism, and it is basically a representation of the various physiological processes that comes under glucose metabolism by a set of mathematical equations. So when you have a set of mathematical equations to represent a particular biological phenomena, sometimes the parameters or the coefficients of that mathematical model is not known to us. So what we generally do is that we try to estimate those parameters from the physiological data, and there we have to go for parameter estimation. So I would be discussing about this, that how optimization can be used to develop a mathematical model for a physiological system, or for that matter, if you have the physiological model, how you can estimate the parameters of the biological model, mathematical model basically. And then I would be coming down to another application of optimization in biomedical engineering. It is relates to digital filter design. So we had an EEG signal, and that EEG signal is highly noisy. And so what we have to do is that we have to remove the noise content in that signal. And what is the best filter that we can design for it? For that, we would be going for a FIR filter. And how that FIR filter can be
Sir, it is not audible, sir.
Due to heavy rain, network issue is here.
Okay, madam.
Please wait.
hello, yes, participants, can you hear me?
Sir, now you are audible.
Yes, sir.
Yeah,
Yes, sir,
actually
you
it is
are.
raining like anything here, you know. You can hear the thunderstorms. It is raining like anything. And okay. Anyway, you will hear a lot of noise, so don't bother about it. Okay, just let me. Okay, so yeah, what I was discussing is, Priyanka, are you here? Priyanka?
Yes, sir, I'm here.
Priyanka, that the moment I get disconnected, now you give me a call. Otherwise,
Yes, sir, sure.
so here, what I was talking is that there are basically two stages in an optimization problem. The first stage is the formulation of the problem. The second stage is the selection of the problem. Sorry, not the selection of the technique. Okay. First, you have to formulate your problem into an optimization problem, and the next thing that you have to do is that you have to, once you have formulated it, you have to select a technique to solve that optimization problem. Now can you tell me, just from your what you call, from your gut feeling or whatever you say, that I think many of you who are doing research might have either worked on optimization, or you might have come across some papers on optimization, right? So can you tell me that which you think is more important, the formulation of the problem or the selection of the technique? See, these are the two things that you always do in any type of research. First, you suppose you are you want to apply machine learning. So first of all, what you have to do, you have to convert your problem into a form so that it can be solved by machine learning or any say. And then in the next stage, what you have to do, once you have converted your problem into a form which can be solved by machine learning, the next thing that you have to do is that you have to select a machine learning technique. Okay, it may be CNN, it may be DNN, it may be encoder or anything like that. So which of the two steps do you think is more important? It is the formulation of the problem, or it is the selection of the technique to solve the problem? Yes, please.
Can I tell? I am Pandianathan from K.
Yes, please go
Ramakrishnan
ahead.
College.
Yes, please.
Pandianathan from K. Ramakrishnan College of Engineering, Tamil
Yes, sir.
Nadu.
Please, please go ahead.
So when you are getting data set, we have to do that pre-processing.
Yes.
Mostly 70% of the job we are doing is pre-processing only.
Yes.
What I am thinking, we have to do first data set, and after that we have to do that pre-processing, and after that it is a 70%. 30% only selection of the algorithms. Anything algorithm, whether it is supervised learning or non-supervised learning. If it
Okay.
is a supervised learning, we can do classification. If it is no label is there, we can do any algorithms like unsupervised learning algorithm. So first we have to do pre-processing the data. That it is
Yes.
my point is that the pre-processing of data is 70%, and the rest is 30%.
Yes. No.
Yes, sir. Thank you.
Okay. Okay.
Yes, sir.
So just he has made a very good point that suppose you have a data set, it is an unlabeled data set. You cannot go for supervised learning. You have to go for unsupervised learning. So that thing is clear. And then you have pre-processed it, removed the outliers, came with the data set, and now you have to select the unsupervised learning technique. So you would find that more or less most of the techniques might give you a result which are, I won't say very close to each other, but somewhere close to each other. But what he said, if your data set is not proper, if the pre-processing technique you have used is not proper, in that case, you may apply the best technique, but even then, you will not get a proper result. Yes or no? Are you able to get it? There are two stages in the problem. First, formulation of the problem, and then selection of the technique. Your formulation, if it is not proper, if your formulation is not proper, then you may apply the best technique. Even then, you will not get the proper result. This is one thing that you have to appreciate. And this holds more in the case of optimization as compared to machine learning. Because optimization, you will find is that I have mentioned here a large number of techniques. I have just a minute. I have written GA, PSO, differential evolution, APC, TLBO, Jaya, and every now and then some new technique is coming out. But what you will find is that there is not much of a difference in the result that you will get when you apply all these techniques. Okay, there will be a difference of, say, for any problem we will see plus minus 5%. Why? Because it is the same problem that different techniques are solving, right? So I will come down to this point. Always keep in mind is that formulation of the problem is more important as compared to the selection of the problem, right? So, and then as I have told you, I would be using I would be discussing about 3 applications of biomedical engineering. One is related to parameter estimation of mathematical models of physiological systems. Okay, by the way, anybody has any idea or can throw some light? What do you mean by mathematical model of physiological systems? Any idea? What does it basically mean? Okay, no issue. I will come down to it later. Yes.
Consider any system, any problem definition, understand how it works, and try to identify what are the parameters which make this particular system, and then represent using some mathematical parameters like it can be optimization problem of maximizing or minimizing some objective. Okay. And having some constraints, because can't.
You have answered my question. Optimization comes later. I have a physiological system. Okay, I have a physiological system. Let us consider that I am taking a particular physiological system of glucose metabolism. Okay. So there is a certain input to this physiological system, maybe food intake, food or carbohydrate intake. The another input may be insulin. Insulin is secreted in our body, and what is the output? The output is blood glucose level. This is a physiological system. Now, I call it X1, I call it X2, I call it X3. These are 3 variables. Now, when I have a mathematical model which represents x3 as a function of x1 and x2, it may be a differential equation that correlates x3 with x1 and x2. It may be a mathematical equation. Now, that mathematical equation is the mathematical model of the physiological system. Okay, why we are calling it as a model? Because the mathematical equations, they will provide you the same solution, that is the same value of x3 when a particular x1 and x2 are there, when we have the similar condition in our body. Right. So that is what you call it as mathematical model. You are right, whatever you have said. And then I come down to digital filter design. I would be discussing about a particular type of filter, digital filter, that is the FIR filter. I think some of you know about it. That is the finite impulse response filter. And how we can use finite impulse response filter, how you can design a finite impulse response filter by using optimization in the best possible manner, how you can design most optimally a FIR filter is something I will discuss. And then I will be discussing about a control system problem. You have a biological control system, and to design that biological control system, how we can use optimization is I will come down as the third case study. Okay. Right. Now, yeah. This is one problem that I suppose all of you might have solved either in your 10 plus 2 or in the first year of your graduation. All of you might have solved this problem. Yes or no? You have a function x and you have to find out a value of, sorry, you have a function f of x and you are supposed to find out a value of x for which f of x is minimum. Okay, so how you can get this x for which f of x is minimum? Yes? Yes, please. This all of you might have solved, the maxima problem or the minima problem. How you solve the minima problem?
So we will take first derivative of f of x.
You take the first derivative of f dash of x. Okay. And then what you do?
Then we will equate it to 0.
0. Okay. And then suppose.
Then we will get x.
Then you will get x star. What is x star? F dash of x at x is equal to x star is equal to 0. Okay. And in the next case, what you do? You take the double derivative of x and then you substitute for x star. If it is positive, you say that it is minima. Okay. And if it is negative, you say that it is maxima. Okay. So this is how you go for maxima or minima. Now, suppose I have a function fx which looks like this. Okay. I have a function fx whose variation with x looks like this. You go by this approach. Will you be able to get this value? What is the value of x for which f of x is minimum for this particular curve that I have drawn? X star is here. But when you go by this approach, there are 2 points which satisfy this condition, not 2 points. How many points are there in this curve which satisfy this condition? F dash of x is equal to 0. That is the slope of fx is equal to 0. How many times the slope of fx is coming out to be 0 here? Yes, please tell me.
5.
5. Once here, once here, once here, here and here. So there will be 5. I call it x1, x2, x3, x4, x5. Okay. Right. So there are 5 points which satisfy this condition f dash of x is equal to 0. And then how many points satisfy this condition? That is both the condition, that is f dash of x is equal to 0 and at the same time f double dash of x is positive. How many points satisfy those conditions?
2 points.
2 points. This point and this point. Now which of the 2 points you will take? Which of the 2 points you will take? You are supposed to take this point. But if the number of, generally what happens, no, for your understanding sake, I have drawn the curve. But in practical cases, this curve is not known to you. Then the curve is not known to you. So if the system is having more such points like this, So in that case, there will be multiple minima points. Yes or no? Try to appreciate this thing. Multiple minima points. There will be more than one minima point. So in that case, what you have to do, you cannot go by this approach. Are you able to get it? What are the problems with this approach? When you have a single point, when your curve is something like this, this is f of x and this is x. In this case, this ambiguity is not here. You have a single minima point, so naturally that single minima point will be a solution to this problem. But when you have a multiple minima points, as we have seen here, in that case, the problem is you have to select from a large number of points, which may not be feasible when the number of points are quite high. Agreed? So that's why in practical cases, and you will find that in most of the research problems, you have cases of multiple minima or multiple maxima. So this classical approach of finding the minimum of a function by taking the slope and then the second derivative is generally not applicable for complex problems. And the another drawback of this problem is that suppose your function f of x is having discontinuities. I suppose you know what you understand by discontinuities. So is the derivative of f of x possible at this point? Yes or no? See, try to get the difference in between a function which is continuous and a function which is discontinuous. This is a discontinuous function. The function that I had previously drawn is a continuous function. Why? Because I can always take the derivative of this function anywhere. But if your function is having discontinuity like this, that there is a sudden jump, what will be the derivative of f of x at x1? Here, suppose this is x1, what will be f dash of x at x is equal to x1? Is it possible? Is this function derivative, the differentiation exists for fx at x1? Yes or no? Yes, please. Anybody? It does not exist. Okay. So in that case, so what I want you people to appreciate is that this is one problem that you have solved in your at school level, you have solved it. Okay, right? But even then, even to this day, there are newer and newer techniques which are coming for optimization. So the question that should come to your mind is that if I have to find out the minimum of a particular function, and there is an approach that exists for finding out the minimum of a particular function, okay, if that technique of, yes, any question? If that technique already exists, why is that we are getting newer and newer techniques quite frequently? Mind it, the thousands of papers that you get on optimization, all of them are basically solving this problem only. Okay, an optimization problem cannot go beyond this. There may be certain constraints that may be added, but the basic problem always remains this. Whatever may be the application, whatever may be the technique, all those papers are solving this particular case, or sorry, this particular problem, right? Now, the one thing that you have to appreciate, see, whenever you are applying a particular technique, it may be a machine learning technique, it would be an optimization technique. The first thing that you have to convince yourself is that whether that technique suits to you or not, it is suitable or not. Now, say for machine learning, say for classification, for clustering, for optimization, if you have to choose a technique, right, what are the things that you should look out for that technique? Selection of a technique. Let us suppose that formulation is what? Formulation is the framing of the problem. Okay. I again come down to this. Formulation is the framing of the problem, and the second stage is the solution of the problem. Now, in this case, if you have to convert your problem into a optimization problem, or you have to frame your problem into an optimization problem, or you have to formulate your problem into an optimization problem, what does it mean? It means that you have to convert your problem into a form like this. Okay, you have to convert your problem into a form like this. And then in the second case, what you have to do, you have to choose a technique to solve this problem. Right. So now can you give me an example in which the problem can be converted into a minimization problem? Yes. Have you understood my question? Let us start with a very basic case. You give me an example of an optimization problem. It may be related to biomedical, it may be related to any other domain. Yes, any application of biomedical or any other domain which is basically a minimization problem or which is basically a maximization problem. Yes. Yes, please answer something. I think this many of you can answer, but yes, please. Okay. I suppose at some point of time, who answered my last question, please, on that, what you call? Yes, who answered the last question? That was an optimization problem, right? Any of you have some idea on clustering or classification, or for that matter, say signal processing? Anybody of you who is working on clustering, classification, pattern recognition, or signal processing? Yes or no?
Sir, I am working with data
yes,
mining techniques, sir.
You are working on?
Data mining techniques, sir.
Data mining techniques
classification. It is biomedical images and data sets, sir.
Data sets. Okay.
Yes, sir. Yeah.
Okay, see.
Thank you.
So
but
let us,
signal processing, I have little bit idea, sir.
Okay, yeah, you have talked of data sets, and now basically, see, one problem which is very common in biomedical engineering is that you have a data set, and what is that you have to do? That data set has to be, maybe it has to be divided into two classes based on that data set is having the characteristics of a group of subjects, and some of those subjects are what you call are normal, and some of those concepts are having some what you call they are suffering from a particular disease. So how will you convert that data set into two classes? It is a perfect classification problem. Okay, so in classification problem, you have a set of data. You have a data, and you have and each data is represented by a set of attributes, and what you have to do is that you have to classify them into two particular class. Okay, now here in this problem, under what case you will say that you have solved the problem to an extent of 100%? You have solved the problem 100% correctly. You are using some data mining technique, and when you can claim that by using that data mining technique, you have divided the data set most perfectly. What is the metric or what is the attribute that you would be looking out for? Yes, madam.
Yeah, we can have a confusion matrix.
You can have it. Let us right now not go for confusion matrix, because that is somewhat one step higher. Let us first talk in terms of accuracy only, classification accuracy. Yes or no? That is the first thing that we try to do.
Yes, sir. Yes, sir.
Yes. Right. So in any classification problem, the one thing that we always try to do is that we try to maximize the classification accuracy. Okay. Right. So if I have to convert that classification problem into a optimization problem, so what I would be doing, I would be converting XFX. I am maximizing what? I am maximizing fx. So in this case, fx is representing what? Fx is representing classification accuracy. And your data set may be like this. Okay, say S1, S2 up to Sn. What is this capital N? Capital N is the number of subjects which you are trying to divide into two groups, normal and a set of subjects who are what you call suffering from a disease. And then along the columns, what we have the attributes. Okay, I call it X1, X2 up to say Xm, capital M. Okay, now when I choose a particular attribute, maybe my classification accuracy, when I choose only X1, I am getting a classification accuracy of 40%. When I choose X2, I get a classification accuracy of 30%. Now, what is your job? You have to choose that particular attribute or that particular characteristics or that particular feature. Most of the times we call it feature. That particular feature in the data set by which we are able to maximize the classification accuracy. So what is X here? You have to choose that X for which f of X is maximized. So in this case, what you have to do? You have to choose that particular attribute out of X1, X2 up to Xm for which the classification accuracy, that is f of X, is maximized. Are you able to get it? Please try to understand it. If you are able to understand it, then the next whatever that I am discussing would be much clearer to you, and in future you would be able to apply optimization in a better manner for your problem. First is that you have a problem. Initially the problem may not be a maximization problem or a minimization problem. Now then you think of how you can convert that maximization, that problem which presently is a classification problem, to a maximization problem or a minimization problem. Then the first thing that you have to look out for is that, am I trying to maximize anything in my problem? Am I trying to minimize anything in my problem? That would correspond, that physical variable would correspond to f of X. And then you have to choose X. What is X? Which is the variable that I will modify by which my aim would be met. What is my aim? My aim right now is to maximize the classification accuracy. So which attribute or which feature I will choose so that my accuracy is maximized. Okay, now the question that should come to your mind is that here there are only m possible cases. So first what I can do, I can take only X1, find the value of fx. I will get f of X1. Then what I will do, I will take X2, find the value of fx2. That is, for each of these attributes or each of these features, I will find out the classification accuracy. So among them, how many such attributes are there or such features are there? Capital M. Okay, so in that case, what I will do, I will calculate m values of fx, and then I will see which of them is maximum. Okay, for which of those x, f of x is maximum, and that will solve my problem. So in that case, what I am doing is that I am not going into the solution. I have formulated the problem into a optimization problem, but as such, I am not using any particular technique. Okay, this may be okay when the number of possible solutions are finite. Here, the number of possible solutions are finite in the sense that what are the possible solutions? X1, X2, X3 up to Xm. So among those finite solutions, you have to choose one solution. So in that case, you can directly do it. But there may be a possibility that the number of solutions may not be finite. In that case, you have to go for a technique. Okay. So once you have formulated the problem, you can solve your problem by using the classical approach of taking the derivative and then taking the double derivative. But here again, the drawback is that in most of the times, your f of x will be quite complex. Once your f of x is quite complex, you cannot go by this approach of finding the derivative or finding the second derivative. In that case, what you have to do is that you have to go for some advanced techniques. And among those advanced techniques, another thing that you have to look out for is that your advanced technique, say for this fx, it should not provide you this solution, this solution or this solution, because these are known as suboptimal solutions. These are not the optimal solution, or these are not the best solution. What is the best solution? The best solution is this one. So if you have to choose a technique which does not provide you suboptimal solutions, but will provide you a solution, this one, which is the best among the suboptimal solutions. So there are two stages here. First is that you have a problem, you try to convert it into a maximization problem, or you try to convert it into a minimization problem. I am not saying that all the problems in the universe can be converted into a minimization problem or a maximization problem, but a large number of problems can be converted. And once you have converted into a maximization problem or a minimization problem, you have to you have to select a technique. So the first technique that you can select is the most simplest technique, or the most classical technique of finding the derivative and finding the second derivative. But here, this particular technique has a drawback. The drawback is that it does not provides you the optimal solution. There is a possibility that it will provide you suboptimal solutions. Why? Because you are only looking for f dash of x is equal to 0 and f double dash of x is positive. That is satisfied for this point, that is satisfied for this point, that is satisfied for this point, that is satisfied for this point. But these are, among those 4 points, there is one point which is globally minimum. Globally minimum is that for the entire range of x, or for the global span of x, this x is minimum, whereas these solutions, they are the local solutions. So you should come up with a technique that does not provide you the global solution, but which actually provides you the, that does not provide you the local solution, but that provides you with the global solution, right? So there are what are the things that you are looking out for in the technique? The technique should provide you the global solutions, and at the same time, it should be applicable to functions which are discontinuous. Like this function is discontinuous. It should be applicable to discontinuous functions also. So I am not going into this because yeah. So and the one technique that satisfies both these two requirements of providing global solution as well as applicability to, just a minute. If you have any question, you please ask. Yeah. So this is what I was talking of. So what are the characteristics that you are looking out for in your problem? One is that it should provide global solution, and it should be applicable to discontinuous functions. Okay, and one group of techniques which satisfies these two conditions is evolutionary optimization. Okay, now here I am not going to the very basics or the history of evolutionary optimization. I'd be giving you a brief idea regarding what are the various techniques that comes under evolutionary optimization, right? And now I have discussed till now I have discussed a bit about what is optimization and how you can convert your problem into an optimization problem. Any maximum problem or any minima problem is an optimization problem, and then once you have formulated it into an optimization problem, the next thing that you have to do is that you have to select a technique. And from the discussion that what we have done over the last 40 minutes, one thing is very clear is that we should have a technique which provides you a global solution, because that is the best solution. Okay, right? And at the same time, since most of the objective the functions f of x, which we call it as, sometimes we call it as the objective function, sometimes we call it as the cost function, Right. So if you have a set of those functions, and in practical cases, in real-time cases, most of the times in research, those functions are highly nonlinear, they are highly discontinuous. So for that, what we have to do is that we have to have a technique which are able to solve those problems, right? And so the next requirement is that whatever the technique that you choose, that should be applicable to discontinuous functions also. Okay. So now because now since I am going to the exact applications and to the types of techniques, now please ask some questions like either exactly related to what I have discussed here, or you have some problem in mind and you want to apply optimization for that problem. We can see that whether it can be converted into a maximum problem or minimum problem, other than the example that I had discussed, that for clustering or classification. Yes, please, anybody?
May I ask a question?
No, please, Rohit, please go ahead. Please.
Yes, sir, I was thinking about, like, we are working in the field of neuroscience, and there are patients with different attributes.
Okay.
For example, if we are looking for a patient with the bipolar disorder and a patient with the schizophrenia. So there are several attributes, like different symptoms on the basis of which you can identify the patient.
Okay.
Yesterday also I was asking a similar question, but the matrix was different. But here I'm asking here, if we have got different variables, how we can find using this optimization approach, like which variable is going to best fit, which one will be the X, which will be how we are going to calculate the M value of X for the best suited variable. My question is making sense, sir?
Yeah, very much. Just let me. Yes,
Thank you.
I get it. Okay, this is one problem that we have solved to a certain extent, and it is quite common in almost all domains of engineering. Okay, now if I have I assume that I have understood the problem properly. Now let me tell you. Okay, so all of you look into this. You have a matrix. Okay, it is a huge matrix. And as Rohit has said, there are a set of subjects, S1, S2, say up to Sm. Now, this particular subject or this particular person or this particular scenario is represented by a set of attributes. Okay, I call it A1, A2 up to Am. Like suppose you can think of that you have like the case of there are a set of people who are represented by a set of attributes, in the sense that what can be the attribute for a particular person? Just a minute. Yes. So now what Rohit is asking is that if you have to classify a set of people, right, and there you are taking an attribute which is distinct or which is discriminatory, and other attribute which is not that discriminatory. What I want to say is that suppose S1 and S2 are belonging to two different classes. Okay, S1 and S2 are belonging to two different classes, in the sense that S1 is having a disorder whereas S2 is normal. So how we can say S1 is having a disorder and S2 is normal? Naturally, the attributes, some of the attributes in S1 will be different from some of the attributes, some of those same attributes in S2, the other subjects. But there is a possibility that some of the attributes, even if these two subjects are belonging to two different classes, there is a possibility that some attributes may be similar. Why that attribute is similar? Because that attribute is not related to that particular type of disorder. Rohit, are you getting it? Yes, Rohit?
Yes, sir. Yes, sir.
Okay. There may be some attributes, like suppose I am taking age. Okay. I don't know, but let us assume that whatever the disorder that I am talking of, age may not be a very discriminatory thing, in the sense that I am talking of a disorder which may happen to people across all the ages. It may happen to a 10-year-old, it can happen to an 80-year-old. So even then, if I take age as an attribute and try to solve that problem, Rohit, would you be able to come up with a proper discrimination in between the subjects?
No, sir, that would not be possible. But
that is, I'm coming, just a minute. A1, A2 up to AN. Now, through optimization, what I can do is that among these attributes, I can identify the best possible combination of attributes through which I can discriminate, or I can divide all these particular type of all these subjects into two groups with the highest classification accuracy. This is something which is rule known as removing redundancy in data set. Removing the redundancy in the data set, it means that there is a certain portion of the data set which is not at all adding to the classification accuracy. Like suppose I can divide the subjects by using A1 or without using A1. A1 is not significantly improving us to include the classification accuracy, or it is not adding any weight to the problem. In that case, what I can do? I can reduce the data set by removing this column. So here the question is, you have a very big data set. In that data set, there are some attributes which may be important, which may not be important. So you have to come up with the best possible combination of the attributes which provides you the maximum classification accuracy while removing the redundancy in the data set. That can easily be done by using optimization, and it is actually a quite explored field. And the another technique that you can somehow here do is that, I don't know whether it has been covered or not, it is partial component analysis, it is dimension reduction. Okay, now Rohit, please you tell me now.
Yes, sir, that makes sense. Thank you.
Okay, right. Now see, this is one thing that you always, that most of you who are working on data mining, or most of you who are working on machine learning, at some point of time you will come across. You have a huge data set, because when you acquire that data set, one thing that somebody has said in the beginning of the class is that pre-processing. In the pre-processing, you can remove the redundant information, or you can remove the noisy information. Okay, the noise also is a very important thing that you have to remove, because if you work with the noisy data, irrespective of whatever the technique, the best technique in the universe you apply it, you write your code in the best possible manner, even then you will not get a proper result. So this pre-processing and problem formulation is very important. And what I am saying, as Rohit has said, is that initially you may come up with a very big data set, and there may be certain components in that data set which may not be required. Why? I am talking only in terms of classification or clustering, because they are adding redundancy. They are not having any, they are not discriminatory. An attribute which is not making any discrimination in between a subject from disorder group and a subject from normal group. So we have to remove them. And how we can identify them? We can identify them by using optimization technique. Okay, so you can think that initially you start with all the attributes, you get some classification accuracy. Then you choose a different combination of the attributes, you get a new classification accuracy. Okay, so what the optimization will do? You are maximizing what? You are maximizing the accuracy by removing the redundancy and by removing the noise component in the data set. That can always be done. Yes. Anybody else, you please.
Hello, sir.
Yes, please go ahead. Please go ahead.
Good afternoon, sir. Sir, actually, I asked this question yesterday that I am dealing with the breast cancer detection. So, sir, so as sir told me that you have to go with the images only. But, sir, can we go with the data augmentation? And in that case, how I can apply the optimization technique? Data augmentation.
So, Goldie, if I to the extent what I know in case of cancer data set, can I assume that your basic task is that if you want to classify them into two groups, one is the malignant, the other is the normal. Okay.
Exactly.
So initially what you have done is that you have taken the images, and the first, after that, I suppose you have extracted some features from that images. Yes or no?
Yes, sir. Yes, sir.
Okay. Now, once you have like the matrix that I have discussed here, in that case, how many rows you have, as many number of images you have, and how many columns you have, as many number of features you have. Okay. Now, maybe the thickness of the cell is one attribute that you have taken from the image. Now, thickness of the cell is something which may not be that much important to divide that subject into a malignant group or a control group, right? Now, if I have understood your question properly, you have extracted the features and you have constructed this matrix. Now, some of the features may be important. Now Goldie, you tell me, if I take all the features and then perform the classification, what is the problem that you will face?
That redundancy reduction, that dimension redundancy, it will be
no. Let us that you have answered the next question that I would be asking you. First, you tell me,
yes, sir.
What problem will you face? This is a question to all of you. You have a very big data set. You are working on that data set. Maybe you want to apply machine learning, you want to apply any wavelet transform, or you want to apply optimization. What is the problem that you face when you work with a very big data set? Yes,
sir, here we may have the problem of the noise because first we have to go for the feature engineering. Then we'll go.
Right. See, this comes after pre-processing. In the pre-processing, we have removed the noise. Okay, whatever the image that we have applied some denoising technique, and then we have come up with the denoised image, and then we have extracted the features. Now, the problem that here is that, again, whatever that you are talking of, this dimension reduction and all that, you will be amazed to know that if you have worked on it, if you are performing classification with 10 attributes, okay, I think let me show this. I think by this you would be able to understand. Now you see, there are a group of subjects, and every subject is represented by two attributes, one along x-axis, the other along as y-axis. So one attribute is represented by this point. It means what? It is having this much value of the attribute along the x-axis and this much value of the attribute along the y-axis. Okay, right? And likewise, what I have done, I have taken, say, S1, S2, n number of subjects or n images, and each of this subject or image is represented by a certain value of x and a certain value of y. All those which are belonging to the control group, they are represented by red. All those which are represented by what you call this malignant group, they are represented by green. Okay, now Goldie, tell me, do you need two attributes to solve this problem, or one attribute is sufficient to solve this problem?
Sir, here we can go with one attribute.
One attribute. Why? Because if you look all these subjects, the value of x is same for all of them. It is only in the second column that there is a differentiation in between S1, S2, S3 up to Sn. So even if you solve this problem by using x, then what you are doing? You are unnecessarily making your problem more complex. The algorithm becomes slower. The execution time becomes larger. Okay. So this is what you understand by dimension reduction. In this case, we are having two attributes. Each attribute corresponds to one dimension. It is a two-dimensional problem. But what we see is that this problem can be solved in one dimension only, because the x dimension is not at all adding something more to the problem. And here I have given you a very simple case. In actual case, the number of dimension may be quite huge. It may be 100 or 120 or even larger. So in that case, what you have to do is that you have to remove those components or those particular attributes or those particular dimension which actually is not adding towards improving the classification accuracy or towards maximizing the classification accuracy. So that comes down to what? That actually comes down to a classification problem. And what is the classification problem here? Choosing those attributes or choosing that particular dimension in the feature space for which we are able to maximize the classification accuracy. Yes, Goldie?
So it means, sir, we are doing here optimization, but in maximize way. We are maximizing the accuracy.
Maximizing
right,
accuracy.
Okay.
Classification.
Thank you so much, sir.
Okay.
Sir,
And
sir,
see,
one more thing. Sir, one more thing. जो data, whatever I was talking about the data augmentation. It means, suppose I am having some repositories, and the values within that repositories are not sufficient or are sufficient, but they are not that much effective. So what should I do with that value? How I can have it in the form of the problem?
This is now you are now what Goldie is talking of a completely different case. Likewise, what we saw is that we are having two attributes, and even with one attribute we were able to solve the problem. Now take another case where we have two attributes, and when by using both the two attributes we are not able to get a proper classification accuracy. I think this is what your question is.
Yes, sir. Okay. Exactly.
So I think it is you are having x, y, you go for a third attribute which is w1x plus w2y. It is some sort of augmentation only. If like sometimes what happens now, that you don't get proper result by using x and y only, then what we do, we take an attribute which is a combination of x1, certain percentage of x and certain percentage of y. You augment that data and then you come down to it. Are you able to get it?
Yes, sir. So that can also be maximize optimization. We can call it as a
ultimately see. Finally, what you have to do, you have to increase the classification accuracy so that all the malignant cases come under one group and all the control cases come under different group. Okay. Yes, so the final problem is an attribution problem. What you call is an optimization problem, and the way that you formulate is different for dimension reduction and dimension augmentation. Okay. Yes, so that is what I am trying all of you people to appreciate, is that it is the formulation of the problem which is more important. The pre-processing and the formulation is more important.
Thank you so much, sir. Thank you, sir.
And for both of you, Rohit and what you call Goldie, I will say that you you may try this particular approach. It is more there also an optimization is involved, but indirectly this part this PCA. Have anybody applied PCA in any case? Principal component analysis. Till to this day, it is the best technique which is available to remove redundancy in the data set, or to remove what you call to reduce the dimension of your problem. Okay. Okay, sir. Yes, see, I think that that if I go on talking about optimization techniques and all that, the whole class may be somewhat less, because this is what I teach over a period of 3 months. But here within the short time, what we can do is that, see, in the present scenario, no, with the optimization toolbox in MATLAB, I think if I get it, I will show you. Don't know whether it is there in my new laptop or not. Keep in mind that again and again, I would like to tell you, it is the formulation which is more important than applying genetic algorithm or particle sum optimization or differential evolution. You will find that my personal observation is that almost all these techniques, they provide a result which is very much closer to each other. Right? Okay. So try to understand the problem. If you are working on denoising, if you are working on image processing, the most important step is the formulation, and even in the formulation, the most important step is, just a minute. The most important step is obtaining the mathematical representation of fx. Okay, this may look out to be very simple. This may look out to be very simple, but as the problem which Goldie and Rohit has said, how to mathematically represent f of x, that is important. And once you are able to do that, you have this optimization toolbox in MATLAB, and you can have other programs also. So like here, just if I get, you can see. Are you able to see this MATLAB screen? Yes or no?
Yes, sir.
Yes. So here, these are all the techniques that you have. Some of them are local techniques, some of them are global techniques. This genetic algorithm is the only heuristic technique that we have. I don't know whether the newer version of MATLABs are having other also. So you don't have to bother about writing the code. Okay. And the only thing that you have to do is that you have to write a function file, and you have to define the function f of x here. Once you are able to do it, you don't have to bother about the optimization technique. But yeah, this will give you some preliminary result, because this toolbox is a generalized toolbox. So it may give you a result, but it may not be the best one. So what I would suggest most of you would do, that we should try to write, you should try to write your own code whenever you are trying to apply any optimization techniques. But yeah, for starting, you can use this optimization toolbox in MATLAB. Right. So anybody has any other question, or otherwise I would be going down to the, what you call.
Sir, do we have any free software available that can be used for optimization?
See, Rohit, again and again, I would like to tell you, most of these techniques, they are freely available. There is I don't know whether there is a dedicated software for optimization or not, but if you go for MATLAB, then most of the techniques, that whatever I have written here, you will get codes for that. Okay, so you don't have to bother about either the coding or for the technique. The important thing is that you frame the function fx properly. The function fx should represent the basic essence of your problem. So yeah, there are like if you go to MATLAB, you can search the codes, and naturally, see, if you are doing research, it cannot be expected that you will do everything by your own. You can take some codes which are freely available in MATLAB Central that you can download, and then you can link that code with your function f of x. It will run. Okay.
Thank you, sir.
Okay. Anybody else? Okay. I suppose, see, there had been some sessions on machine learning, I suppose, previously. Maybe either yesterday or day before it. Yes or no?
Yes, sir. Yes, sir.
Okay. Now you have whenever you are now, what are the machine learning techniques that were discussed?
Some basics were told, like supervised, unsupervised techniques.
Supervised, unsupervised learning. Okay, let us start with the most basic. If you are trying to implement a artificial neural network for your problem. Okay. So what are the challenges there? Or maybe you are trying to implement a convolution neural network or a deep neural network. What are the challenges there? First challenge. The first primary challenge is that you have to select the architecture of the artificial neural network, convolution neural network, deep neural network or not. Is that a challenge, or you have a architecture which is applicable to all problems in the universe, or different problems needs a different architecture? By different architecture, I mean how many number of layers will be there. Yes, Govind Swami, please.
Sir, it may be based on what type of a data set
Yeah,
we take
exactly.
and apply it for.
So better don't say data set, better
Yes,
say
application.
application or the problem.
Yes.
So suppose you have a particular application, you have a particular data set and you want to apply CNN. So the first problem that you will face is that you have to select a proper architecture. By proper architecture, I mean to say is that how many input layers will be there, how many output layers will be there, what would be there in between the input and the output layers. How that is generally done? What is the approach that is followed? Yes, Govind. What is the approach that is generally followed to select the architecture or to select the structure? Yes, Govind. I think he's not connected now. So yes, anybody? See, if you are using machine learning, say CNN or anything like that, and you are using any software, okay, it may use MATLAB or using Kerasa or anything like that. So the first thing that you have to do is that you have to select a proper structure, and you would find that the performance of any technique, any machine learning technique is heavily dependent on the proper selection of the structure. And mind you, you will find that over the last few years, there has been many problems, but there has been many papers where people have applied optimization techniques to to select the best architecture of a machine learning technique, right? You have papers where this optimization techniques has been applied to select the CNN architecture. You have papers where optimization techniques have been applied to select the architecture of an artificial neural network, of a deep neural network. So that is an important application of optimization which has recently come up, right? Because selecting a proper structure is very important. I say that you may apply the best CNN, right? But if your structure is not proper, you will get the proper result, and optimization helps you in selecting a proper structure, right? So I will quickly come down to these three applications that I have. Okay. Anyway, I will share this lecture, and after that, see, this is one problem that I did during my PhD about 13 years back, and it was related to mathematical modeling and parameter estimation. Like anybody of you who is working on mathematical modeling of physiological systems or systems biology? Anybody working on systems biology or mathematical modeling of physiological systems? Okay, so here what we are having is that the glucose metabolism is represented by this block diagram above. So what we have here, a person is taking a certain food of certain carbohydrate content. Okay, so what happens? The carbohydrate, the food goes inside, the metabolism takes place, the carbohydrates gets converted into glucose, the glucose level rises, and then when the glucose level rises, what happens? This is the insulin subsystem, and insulin is secreted. Okay, certain part of the insulin is stored in the liver, and that insulin, whatever is is secreted by the pancreas, it tries to reduce the value of the glucose. Okay, now this is a mathematical model which correlates glucose with insulin and a certain form of insulin which actually brings down the level of glucose. Okay, so there are three physiological variables here. One is glucose, the other is insulin, and then there is a non-physiological variable, capital X, which represents an intermediate form of insulin. Now, whatever the reactions that go inside your body whenever you take a particular quantity of food, that how the glucose level initially rises and then it comes down, that is represented by these two mathematical equations. Okay. Now I ask you a simple question. All of you have come across differential equations in your undergraduation, or even of you who are from biological background, at least you have seen these equations in physics. These are simple differential equations, second order differential equations. Now, this differential equation is represented by there are three variables: glucose, insulin, and intermediate form of insulin, which brings down the level of glucose. These are the three variables, and there are certain coefficients in this mathematical equation, certain constants, which are P1, P2, and P3. Okay, what I say is that whatever the reactions that go inside your body when you take your food, it gets converted to glucose, the glucose level rises, and then the insulin is secreted. It is represented by these two mathematical equations, whose coefficients are P1, P2, P3. Now you tell me, a person who is diabetic and a person who is non-diabetic, in what way these two equations will vary for those two people? Are you able to get it? You have a set of yes,
insulin secretion will be varied.
The insulin secretion will be normal for a normal subject, whereas the insulin secretion will be very low for a diabetic subject. But that is the physiological thing that you are talking of. Now try to correlate with these two equations. How will these two equations change? These two equations are the mathematical representation of the glucose model, of the glucose metabolism. How these two equations will change for a person who is diabetic and a person who is normal? Talk in terms of the equation, the one that is there inside this red border. Everything will be same or something will be different? Yes, please.
So it will be same, sir.
No, it will not be same. It will be same. The basic form of the equations will remain same. But as far as these coefficients are concerned, P1, P2, and P3, will that be also same?
No, sir.
Isn't it?
No.
No, yeah. The basic equations, what you have said is correct. The basic equation parameters P or which are the specific characteristics of the mathematical equations, or if they are if they are characterizing the mathematical equation, it also means that they are characterizing the physiological phenomena which is represented by the mathematical equation. So there is a whole lot of research that is going on in there. In that research, what they do is that, first of all, they conduct some test on a subject, and then they take the glucose and insulin data over a period of time, say 5 hours or 10 hours, and from that data they try to find out the value of P1, P2, P3. Are you able to get it? It is the classical approach of finding whether a person is diabetic or not. That is generally done by the fasting blood glucose level. But in case of, if you want to get a better diagnosis, there are other approaches available. But one approach where a mathematical model is used is what I have shown here, is that in that case, we have the data. Data is where a test is conducted on that subject, and that in that test, you get a data of insulin, glucose, like the data is something like this: time, insulin, and glucose. Like say 0, 1 second, 2 second, 3 second, 4 second, not 4 second, but over a period of time. Insulin and glucose are not something which changes in with such rapidity. So you take this data, and then we feed this data to this model and find out the value of P1, P2, P3. So there we have applied optimization. What we have done is that the name of the test is IVGTT. So in that case, what is done is that we take the data and we try to fit the model. This is the output of the model. We simulate it in MATLAB with a random value of P1, P2, P3. Initially, we start with a random value of P1, P2, P3, solve the equation, and then we try to compare the glucose value that we have got with the actual experimental data. If they are matching with each other, it means that we have taken the proper value of V1, P1, P2, P3. If they are not matching with each other, we have to update the value. So this is how we have formulated the objective function or the cost function for the problem. And once we have done it, once we have represented f of x mathematically, what we have done is that we have converted our problem of parameter estimation or our problem of diabetes diagnosis to an optimization problem, and then we try to minimize it. Have you got it?
Yes, sir. Yes, sir.
Please. Yeah, at least after that, what we have done is that we have applied here 5 techniques. Okay, if I remember properly, it was PSO, particle sum optimization, differential evaluation, genetic algorithm, and ABC. And you would be amazed to know that for all the 3 cases, more or less, we are getting the similar values of P1, P2, P3. Okay, just a minute. हेलो हाँ मैंने अप्लाई किया था आप 5 मिनट बाद 10 मिनट बाद कॉल कर सकते हैं प्लीज right. So what I again try to reiterate is that you frame it properly, you represent the function f of x properly by proper mathematical model or proper equation, and then whatever the technique that you apply, more or less it will give you the similar result. And I'm not going into this now. I think anybody of you who is working on filter design, yes or no? Okay, so suppose that you have a biological signal, it may be ECG, it may be EG, it may be EMG or anything like that, and you have to filter that signal. Okay, so filter that signal is that you have to remove maybe the high frequency components in that signal. So for that we are designing a low pass filter whose characteristics is shown here, right? So an ideal low pass filter is something like this, but if you talk of a practical filter and a finite impulse response filter, then in that case the response will be something like this. I don't know how many of you are from this either electrical or electronics background. Anyway, so each filter is represented by a set of filter coefficients, okay, which is H0, H1, H2. These are the unknowns, or these are the attributes of any filter. Now you have to design a filter. For that a certain specifications are given. And what are the specifications? The specifications are, sir, 5 minutes. Okay, so when you have a filter which is represented by these coefficients, right, and you have a certain specifications of a filter, in the sense that in this band, this much should be the ripple. It may be 0.1, 0.2, 0.3, and then in the stop band, this much should be the ripple. It should be 0.2, 0.3, 0.4, anything like that. So what your job, and if I change the value of H0, H1, H2 up to Hn, in that case what will happen? Your filter may become something like this. It may reduce, it may increase, or anything like that. The total response will change. So what I want is that I want 0.1 here, and I want 0.2 here. To attain this 0.1 and 0.2 here, I should have a proper combination of these elements of this array. So how to come up with this H vector so that every H vector is characterized by a different response. And among those infinite for each of those combinations of H, there is one filter. And among those infinite combination of H, or among those infinite filters, you have to find out one filter for which this ripple is 0.1 and this ripple is 0.2. So for that, what you have to do, you can apply optimization technique, and you can find the most optimal H vector for which your criteria for FI for repel in the pass band and in the stop band is attained. Okay. So this is how we have used FIR filter design as an optimization problem. Again, I won't discuss much into it, and because I understand that those of you who have not studied DSP, you would find it difficult. Okay. So what I would do is that right now I would stop my presentation, and if you have some specific questions like the way Rohit and Goldie has asked, you please ask those questions. I will be very happy to answer you to answer that. Yes, anybody? It may be either exactly related to the techniques that I have discussed, or it may be related to the formulation that I have discussed, and then or anything that you have a certain frame of mind, you have tried to apply optimization for your problem but failed somewhere, or you are thinking of applying optimization. I'd be very happy to answer.
Sir, I am having one more question. So,
Yes.
sir, as you have used objective function and cost function,
I think can you be louder?
sir, as you have
Yes.
told us about the objective function or the cost function, so can you tell us something about that cost function? What is exactly an objective function?
Cost function is, see, cost function is the essence of your problem. If your cost function is not proper, whatever the technique that you have discussed, whatever the technique that you will apply, even the best technique you apply, you will not get a proper result. Now, cost function is something which mathematically represents your problem to make it as simple as possible. So what is there in the cost function? You have f and you have x. First of all, you have to identify what is f. Like for the question that you have asked, what is f? What is the thing that you are trying to maximize? You are trying to maximize accuracy. So that f is accuracy. And what is x? Which parameter you will vary to improve the accuracy? You will vary the attributes. So x may be 1. When I say 1, it means that it is the first attribute. When I mean x may be 2, it may be the second attribute. So fx is the mathematical representation of your problem. To mathematically represent f of x, you have to identify two things. One is f and the other is x. So the first thing that you have to do is that you have to identify f. F is your problem. So f is accuracy. It may be what to call accuracy, or it may be the various components of the confusion matrix, true, positive, true, negative, like that. And which parameter you will vary to maximize f, that is accuracy, that will be your x. So you have to come up with a mathematical function that correlates the objective, which is accuracy, with x, that is the attribute. Is it clear?
Thank you, sir. Thank you, sir. Thank you.
Harjit, thank you, but please ask something. Harjit, what is your domain?
Good afternoon, sir.
Yes, please, Harjit.
Yeah, sir, I am working in linguistics, sir.
In linguistics, okay.
Yes, sir.
So any signal you acquire and then you do some processing on it?
No. Right now, sir, I am not doing, sir.
Okay.
Yes, sir. Thank you so much, sir.
Is there any more questions from participants?
No.
So can we end this session, sir?
Okay, thank you.
Thank you so much, sir.
Okay, thank you. And I don't know that to what extent I have covered it, because the time was less. So what you do, the basic idea is that you should try to appreciate how you can apply optimization and how you have. So how is more important? Applying framing the optimization problem, framing the objective function is more important than selection of the techniques. This is the bottom line that I have to say. Okay. Yes, Priyanka, you can conclude.
Yes, sir. Thank you, sir. So participants, right now there will be a lunch break for you. We will meet again at 3 p.m. Thank you.